Hey ladies, welcome back. Miss Erin Sebia here. Last week we went over basic operations and, kind of the basics of naming and discussing polynomial functions. Today we're going to be talking more about operations when we have more than one polynomial function and also something called the composition of functions. So let's get started. So operations of functions, we're already used to the idea that we can add two different polynomials together. We're just going to be kind of going over the notation of how to do this. So for example, let's say I had f of x and let's say I had g of x. Okay? So they tell me that f of x is equal to 3x minus 7 and g of x is equal to 13 minus 2x. Then they tell us to find f of x plus g of x. Well, what I'm going to do is I'm going to write out my f of x, which is 3x minus 7, and they want us to add it to our g of x. So I'm adding it to 13 minus 2x. So again, all I did was plug in what I knew, and I'm just going to move forward. I'm just going to combine like terms. Before we get started though, I do want to give you guys kind of something that might help you in the long run. If you want to start now, I would get in the habit of plugging things in with parentheses, as I've, kind of harped on in the past. I didn't really use parentheses for this particular example just because, we're doing addition and we know that addition doesn't really change the signs of our polynomials, but, just looking forward, especially if we have subtraction, definitely get in the habit of using parentheses. So our second step was to combine like terms, right? So I'm going to look for my highest degree. It seems we share x's here, so I have 3x minus 2x, that leaves me with 1x, and I have negative 7 plus 13, which leaves me with 6. So my answer, when I added f of x and g of x, is x plus 6. This new function is called f plus g of x. And again, our answer was x plus 6. So there's a bunch of different operations. We have this addition where, we added f of x and g of x. You might also see subtraction where we have f of x minus g of x. And the order of these functions do matter, right? So if there was a g here, the g would go first and we would be subtracting f, okay? We have multiplication. So we have f of x times g of x. And we have division, so our quotient. So we have f of x divided by g of x. And I have a little star here. The reason why I have a star here is because we're going to be talking about something called a restriction. So in math, we are used to the idea that we can have numbers and variables on top, but we cannot have a 0 in the denominator. This is undefined. This is something that we don't want. So when we have a polynomial in our denominator, we have to make sure to kind of restrict our domain so that this denominator is never 0. So we never want 0 here. And I'll show you guys how to do that in just a little bit. So let's look at our next part. So it says, given the function f of x is equal to x squared minus 8x plus 4, g of x is equal to 4x minus 3, and h of x is equal to x plus 2, find each function. We will be indicating as well any restrictions on the domain. So that's going to definitely work with this whole idea of the quotient. They can be a little tricky, so when we get there, I'm going to go nice and slow. So number one's pretty simple, right? We have f plus g of x. So I'm going to look at my f of x. So my f of x is right here. And I have my g of x as well. And I'll just make that blue. So I have, actually, instead of using yellow, let me use pink. That way I can actually write with pink and I can actually write with blue. Okay, so I have my f of x. That is x squared minus 8x plus 4. We are going to be adding it with g of x. So again, I did mention before to get in the habit of using parentheses. Since this is addition, I know that my parentheses are going to drop anyway, so I just didn't include them here, but I will be including them with my other examples. So I'm going to combine like terms. First and foremost, I'm going to notice that I have x squared here. He is my leading term just because he has the highest degree. I have x's, so I have negative 8x plus 4x, so that will give me a negative 4x. And I have a 4 minus 3, that leaves me with 1. So my new function is right here, my new polynomial. We have x squared minus 4x plus 1. So let's look at 2. So I have, let me color code my h to be green. So I have f minus h of x. So my f was in pink, so let me swap over to pink. So I have x squared minus 8x plus 4. And since it's a subtraction, I am going to put parentheses around this because we do know that this negative sign is going to cause some trauma here. And we have minus h of x, which is x plus 2. So in our past problems, we did talk about how minus signs here, when we distribute them, will change the sign. So for example, I'm going to distribute this to my x and to my 2. So when I rewrite this, I'm going to have x squared minus 8x plus 4. And now negative times x gives me a negative x. And negative times 2 will give me a negative 2. So all I did was I changed the sign. And I'll put a little star. Don't forget your negative sign. Very important. He will be changing your signs. He's very tricky. So now, just like number 1, I'm going to combine like terms. I see that I have x squared. He's my leading. I'm going to scratch him out. I have a negative 8x and a negative x. That will give me a negative 9x. And I have a 4 and a negative 2. So 4 minus 2 gives me 2. Okay, let's look at 3. So I have multiplication here. I have h times g of x. So my h is x plus 2. And my g is 4x minus 3. And we did go over this in our last video, so if you guys kind of struggle with multiplication, please go back, watch that video. This will be a double distribution. So I'm going to distribute this x. So I have x times 4x gives me 4x squared. And x times negative 3 gives me a negative 3x. Now I have 2 times 4x, that will give me a positive 8x. And 2 times negative 3, that will give me a negative 6. So I'm going to go ahead and I'm going to combine like terms. I have my x squared, he is leading, he's my biggest degree. I have a negative 3x and a positive 8x, that will give me 5x. And I have a negative 6, so he'll go at the end. Okay, now I have f divided by h of x. So my f is x squared minus 8x plus 4, and my h is x plus 2. Okay, so I can't actually simplify this. Let's say that this was something that could be factored. So let me give you an example. Let me see. So let's say I had x squared minus 4x plus 4. And let's say this was all over x plus 2. I could factor my top. So for example, let's make this a positive actually. So for example, this top, and as we learned before, this could be factored into x plus 2 and x plus 2. And this is still all over x plus 2, right? What do you notice is going to happen here? Well, this and this would cancel out. It could be the same where I could cancel this and this out. You know, it doesn't really matter. I'm just going to cancel the first one out again. But I would be left with this x plus 2 here. Well, in this particular example for number 4, I actually can't simplify. This numerator up here, what I have in pink, does not simplify. It does not factor. This is something I'd have to use the quadratic formula on, but it's never going to cancel out with this x plus 2 on the bottom. So we have to deal with something that we call a restriction. So although this is our final answer, I need to tack something onto it. And the way I'm going to do that is I'm going to look at the denominator. So I'm going to put a little star here, and I'm going to put look at the denominator. So for example, I have x plus 2. What I'm going to do is I'm going to set it equal to 0 because we don't want it to be 0, right? So we want to figure out, well, what value makes the 0? Well, I'm going to solve for x. So if I want x alone, I'm going to move that 2 to the other side. So x is equal to negative 2. So what this means is whenever x is negative 2, I get a 0 in the denominator. And that makes sense because negative 2 plus 2 is 0. So what I want to include is that in my domain, x cannot be negative 2. So that's something I want to add on to my answer. So let's recap. If I have, let me switch to my highlighter. If I have something like this that cannot simplify, and I have something in the denominator, what I did was I looked at that denominator, I set it equal to 0, and I solved for x to figure out what that restriction would need to be. And I found out that x could not be negative 2, because if x is negative 2, we get a 0 in the denominator, we get something that's undefined, we do not want that. So I just wrote this little restriction here. I said, hey, we don't want x to be negative 2. But let's say we have an example where we can simplify. Well, just factor like normal, simplify, you guys are good to go. Okay? So let's look at number 5. So we're going to have a very, very similar situation here. So what I'm going to do is I have my h, which is up here. So I have x plus 2, all over my g, which is 4x minus 3. So this one, I can't cancel anything out either. This is very similar to our answer to number 4. But since it is division, I need to go ahead and I need to look at that restriction. So again, I'm looking at the denominator. So I have 4x minus 3. I'm setting it equal to 0, and I'm going to solve for x. So I'm going to add this 3 to the other side. I have 4x. I'm going to divide both sides by 4, so I get my x alone. And I get that x is equal to negative 3. So whenever I get, not negative 3, x is equal to 3/4, sorry. So whenever x is equal to 3/4, that's when I'm going to have an undefined value in my denominator. So we do not want that. So what I'm going to do is I'm going to write a restriction saying that I do not want x to be 3/4. I don't know where that line just came from. Let me try that one more time. Okay, so I have my two answers here, right? I have my piece where I plugged in my functions. I have my domain restriction. This tells me, hey, no 3/4 in the denominator, please, to survive, and you guys are good to go. So let's look at number 6, just your typical multiplication problem. So I have f times g, so I'm going to plug in my f. So I have x squared minus 8x plus 4, and my g is 4x minus 3. Okay, so you guys know how to multiply this out already. I'm just going to write the answer at the bottom just for the sake of time, but feel free to work that out. You should get 4x to the third minus 35x squared plus 40x minus 12. That should be your answer. Okay, let me jump down to number 7. So 7 through 10 are the same exact thing that we did above. The only difference is this value right here. Okay, so what it's telling you with that little parentheses is it's telling you to plug in this number. So some kids prefer to do the function part first and then plug in the number. My recommendation to you as someone that's done this for a long time is to just plug in the number first. And the reason why is f and g is pretty simple, right? Adding these two functions together and then plugging in -2 seems pretty straightforward. But you guys remember how much of a pain in the butt multiplication is. Would it be easier to multiply these two functions together and then plug in a number? Or do you think it would be easier just to multiply two little numbers together? Of course it's going to be much easier just to plug in and multiply two numbers. So it's my recommendation to you just to plug in those numbers first and then do whatever it's telling you to do. So for example, let's find what f of negative 2 is. So we know that f is right here. Oops. So f is right here. And let's make our g blue. So we have, let's see, I'm going to plug in negative 2. So 2, I'm plugging in negative 2 minus negative 2 minus 12. And if you guys throw that into your calculator, you will get negative 2 as your value for f. So let's plug in g. So g of negative 2, and we have negative 2 plus 7, and that's going to give me 5. So if I were to do f plus g, I get negative 2 because that's what f was, right? Plus 5 because that's what g was, and my answer ends up being 3. Okay? So I think these are a little bit more straightforward. I think it's easier to plug in numbers, to be very honest with you, than to just have the polynomials and, multiplying all these x's, etc., etc. I think plugging in numbers is a little bit faster. So let's see. I have f minus g. So my f, and it's of 8. So let's go ahead. Let's plug in 8 to both of these. So f of 8, I'm going to be plugging in 8. And when I plug in 8 into this function, I get 108. So let's do g. So g of 8 is 8 plus 7, and that's going to give me 15. And now what they want me to do is they want f minus g. So what is f minus g of 8? Well, we have 108 minus 15, and that's going to give me 93. Okay. So 9, let's see, they want us to plug in negative 1. So f of negative 1, I'm going to go ahead, plug in negative 1 everywhere I see an x. Oops. Minus negative 1 minus 12. And let's see, 2 times negative 1 squared minus times negative 1 minus 12. That's going to give me negative 9. And let's go ahead, let's plug in g of negative 1. So I'll have negative 1 plus 7, and that's going to give me 6. All right. So what is it asking me to do now? It's asking me for f times g, and we have a negative 9 times 6, and that's going to give me a negative 54. All right, and 10. So when we are actually plugging in a number, you're going to notice that I'm not going to actually have to make a restriction because I'm going to have just a regular fraction that we're used to seeing. It's not going to be some polynomial expression where I have to actually restrict the domain. So let's give this a look. So let's see, f of 5 is, so I have 2, 5 squared minus 5 minus 12, and that's going to give me 33. And my g of 5 is 5 plus 7, which is 12. And they want f in the numerator and g in the denominator. So let's say f over g is going to give me 33 over 12. And this does not simplify. That's actually just what your fraction is going to be. All right, so let's talk about the composition of functions. So the composition of functions is as if I were telling you to plug in a function into another function. So how you would say this in real life is f of g of x. So again, another way that we can combine functions is something called a composition, where if we were given f and g, we would be plugging in one function into the other. So for example, if I had it written like this, this would be, so let's say I had it written like this. This would be seen as plugging in g of x into f. Okay? So let's give this a try. And again, this is pronounced out loud, f of g of x. So what is actually happening here, and let me just use some color so you can see it. We are plugging x into g, and whatever we got from here, we're plugging it into f. So let's give this a try. So I'm going to look, let's see, I have given f of x is equal to x to the third plus 8, g of x is equal to x minus 1, and h of x is 5x minus 3. We're going to be finding the compositions of functions. So something that I think is a little bit easier to see, some kids kind of struggle with this notation here. So if you want to rewrite it, go for it. This is the same thing as seeing us plug in g of x into f. So what I'm going to do is I have my g of x, that is x minus 1. My f of x is x to the third plus 8. And what I'm going to do is I'm going to literally take x minus 1 and plug it into where I see this x here. So my f of g of x, we know that we have f of x as being x to the third plus 8, and we want to plug in x minus 1 in for that x. So I have x minus 1 to the third plus 8. So again, what I did was I saw that I had this x right here, and I know that I have to plug in g of x in for my x. So I took this x minus 1 and I plugged it in for this x, and I just rewrote it. Something you guys will also notice is that this is not the final answer. You technically have to rewrite this. So we know that we see this 3 times. Sorry, I said 3 and then I wrote it out. And theoretically speaking, you would multiply these 3 out, you would do your triple distribution, etc., etc. And I highly recommend you try doing that. I'm just going to write down the answer just to kind of save us some time. So once you multiply that all out together, you know, distributing multiple times over and over again, simplifying, putting all your terms in order, you will get x to the third minus 3x squared plus 3x plus 7. And please, if you guys get something different here when you're doing the math yourself, just message me, just show me your work. I'll be more than happy to help you. I'm just trying to cut down on the time, to be very honest with you. I don't want these videos to be super long. Okay, so number 12. So what this is telling me is we are plugging g of x into h. So again, we go backwards, right? We plug this into that, and then this into this. So I'm going to be plugging in whatever I have for g into h of x. So here I have that g is x minus 1, and I'm going to be plugging it in right where I see an x. So I have 5, and instead of x, I have to plug in what I know what g is. So I have x minus 1, and I still have this minus 3. Okay, so we can simplify this a little bit. I'm going to multiply 5 in. So I have 5 times x gives me 5x. 5 times negative 1 gives me negative 5. We still have this minus 3. And these two can definitely combine. So I'm left with 5x minus 8. Let's say that you guys aren't seeing the visual. Let me try doing some color coding because, you know, in class I would be able to know immediately if you were understanding this or not. Since I'm recording this video before you guys ask me questions, I'm going to try to do my best to figure out what you guys are going to ask. So let me try this one other way, just to kind of give you a visual. So I know that I have h g of x, right? And let me color code h to be something. So let's color code h to be green. So I know that my h is on the outside, right? So he's going to go first. So I have 5x minus 3. Well, now I know that I have to plug in g in there, right? I need to have g here. So what I'm going to do is I'm going to change this x to be whatever g is. So I still have this 5, I still have this minus 3, but that x has to change to whatever g is. So I have that x minus 1. Okay? And then, like before, you can use distribution, and you would be left with 5x minus 8. Okay, so let's try 13. So here for 13, I'm going to be plugging in h into f. So I have f h of x. So this is going to be an ugly one just because f is x to the third. So I'm going to plug in h into f of x. We know that h is 5x minus 3, and I want to plug that into the x and f. So I have, originally I had x to the third plus 8, and we are taking this 5x minus 3. We are plugging this in for this x. So I have 5x minus 3 to the third plus 8. So again, I took h, I plugged it in for that x that we have in f. I have this right here that I'm left with. And as said before, I know that this is to the third. You do have to simplify it. It's a real pain in the butt. So you would go ahead, you would multiply these all out, just like you guys are used to. It's a very tedious process. You have to be very careful. Like before, I'm just going to give you guys the answer. I'm going to tell you guys to do that work by yourselves. Honestly, just try to get the practice, because you will see this a lot next year, especially if you have me. So I'm just going to write down the answer just for the sake of time. Feel free to reach out. I will do the work with you if you want me to. So I have x to the third minus 225x squared plus 135x minus 19. So this would be the answer once you multiply this all out, simplify, combine like terms, etc., etc. And let's do 14. So I know that this is going into this, and these are going in there. So this is g of f of x. So I'm going to be plugging in f into g. So I know that my g is x minus 1. My f is x to the third plus 8. This is going in here because we want to plug in f into g. So I have x to the third plus 8 minus 1. This is actually pretty nice to simplify because only the 8 and the negative 1 can combine. So this ends up being x to the third plus 7, since 8 minus 1 gives me 7. Okay, and with numbers, this process is so much easier. I love, 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 love this. So let's find what h of 2 is, because as said before, this is g of h of 2. So what do I need to find first? Well, I need to find what h of 2 is. So what is h of 2? Well, h is 5x minus 3, and I'm going to be plugging in 2 for x. So I have 5 times 2 minus 3. 5 times 2 is 10, minus 3 gives me 7. So now what this becomes is, instead of h of 2, we know that h of 2 is 7. So I'm going to be plugging in 7 into g, because I know that h of 2 is 7. So now I have g of 7, and I'm going to be plugging 7 into g, so that will be 7 minus 1, and that's going to give me 6. So I love these. These are kind of like riddles. I think as soon as we involve numbers, the whole process becomes a lot easier. So let's rewrite this. I have h of f of negative 6. I'm going to be plugging in negative 6 into f. So I have f of negative 6. That gives me negative 6 to the third plus 8. And let's see. Negative 6 to the third plus 8, that will give me negative 208. So I'm going to write this now, okay? So we know that f of negative 6 is negative 208. So really, I'm just going to rewrite it. And I'm going to be plugging in negative 208 into h. So h of negative 208. My h is 5x minus 3, so where I have that x, I'm going to change it for 208, negative 208, sorry, minus 3. And 5 times negative 208 minus 3, this will give me negative 1,043. Okay, so that pretty much wraps everything up. I highly recommend you guys download the Desmos calculator or maybe use it on your Chromebooks. Feel free to message me at any time. If you want to see these, crazy problems worked out piece by piece, I would more than love to work them out for you. It's not a problem. I just wanted to save some time on here because, that gets to be super lengthy and messy. Please, please, please reach out to me. I love hearing you guys reach out, and look forward to seeing you guys in the fall.